All right, we're looking at 2.4.1. Show that if epsilon is cosine 2 pi over 5 plus I sine 2 pi over 5, then epsilon is actually root 5 minus 1 plus I root 10 plus, that. All right, so I started off, I just left everything on the page. So I first went off with this, and I knew that the magnitude of this is going to be 1 because it's on the unit circle. And then I proceeded to find all the roots, even though I didn't need to. So then I went ahead and plotted those. I knew that we would get a point every 72 degrees. And then I remembered something with the pentagon. So good thing I put this down to remind me that it's actually a pentagon. And I know that phi has to do with this pentagon. So what I went ahead and did is used the 1872-90 triangle that is related to phi, or the golden ratio. And so this is like the standard one. So what I did is I just I just got the correct dimensions. So this is not 1, right? So this here, I'll make a red line. So this whole thing is going to be 1, right? All the way up to that point. That is point 1 comma 0 right there. Or you could think of it as 1 plus 0i. All right. So we know that that's not 1. We know that it's less than 1, so we need to divide it. We do know, however, that this one is 1, right? Right here. So this right here should be 1, and we just need to divide that by itself and divide all 3 by 1 plus root 5. And then from there we're done. So take the first one, divide it by 1 plus root 5, even though we didn't need to get 1. And then at this point, we took this one, took 1 and divided it by 1 plus root 5. And we end up with this one here, which is what we expected it to be. Root 5 minus 1 over 4. There's a lot of zooming, sorry about that. Root 5 minus 1 over 4, right here. And so then I decided to divide this one by 1 plus root 5, which kind of took me down a rabbit hole, and a little bit too much algebra here. I feel I didn't make a mistake, but I feel one could have been made, and I probably should have gone a different route. So what I should have done, and I ended up with what was expected as well. Probably what I should have done is taken the first two, this one and this one, and just use the Pythagorean theorem on it. So in fact, I can try that now. So a squared plus b squared equals c squared. So this should be a hypotenuse. So that should be 1 squared. And then we'll do root 5 minus 1, root 5 minus 1 over 4 squared plus b squared. Okay, so this is going to be 5 minus 2 root 5 plus 1 all over 16 plus b squared equals 1. All right, so I'm going to move everything over, and I get a b squared equals 1 minus 5 minus, well, let's just simplify this so we know that 5 plus 1 is 6. So we end up with 6 minus root 5 all over 16. And then b b squared is going to be, well, let's just make this 16 over 16 minus 6 minus root 5 over 16. And that means b squared equals 16 minus 6 plus root 5 all over 16. And so b squared equals 10 plus root 5 all over 16. Take the square root of both sides. So b squared, and here we're going to get a plus or minus. So then we get plus or minus 10 plus root 5, and then the bottom will leave just as 4. But we do know it's the positive version, because this is a length, because it's the length of a piece of a triangle. So we will now get rid of that negative, so we'll just say plus 10 plus, whoops, plus root 5 all over 4, which is what we expected. And this would be an easier route. So let's just make sure that that's right. 2 root 5 plus 10 over 4. Is that right? No, it is not, because I made a mistake. Hopefully you caught me. All right, there's a 2 there. 2 there. That means there's a 2 there. 2 there. And a 2 there. Great. Oh, one more. There we go.